In Chapter 7, we're looking at conic sections, and in this blurb I've given you, I describe how the conic sections are cross-sections of a double-napped cone. But if you don't know what that looks like, let me show you. The book has this illustration of two cones kind of sitting end to end, and if a plane passes through it perfectly horizontal, I get a circle. A little bit of an angle, I get an ellipse. If it's so much at an angle that it's only passing through one side of it and not touching the other, then I get a parabola, which is what we open Chapter 7 with. And if it's passing through vertically, then it creates a hyperbola. So another way that we describe these conics is as a locus of something. And a locus is just a set of points that fits a certain description. So a parabola is a locus of points that's equidistant from a given point, called the focus, and a given line, called the directrix. So one of the main things that we're doing in this lesson is, given the equation, let's figure out what the focus is, what the directrix is, and of course we're graphing them. A few key pieces of information. If the x is what's being squared, you know it's going to open up or down. If this value of p is positive, that means it's opening up. If it's negative, it's going down. The vertex is h comma k. There's our favorite letters in the whole wide world. And a little bit different from the other h and k that we've seen all year long. All year long, you've heard me say that x is the opposite of what you see, but k always does what it's supposed to. Here, notice that they're both x minus and y minus. So keep that in mind. The book treats the focus and the directrix in a very formulaic manner. I don't like formulas. Maybe you've noticed by now. And so I'd rather you think of them conceptually, and that's how I'm going to show you how to find the focus and directrix in example 1. Over here, notice if the y is being squared, that means it's opening horizontally. Kind of the same idea. If p is positive, it's opening in a positive direction. If it's negative, then it's opening in a negative direction. So let's begin. In example 1a, the vertex is right here staring at us. It is 4, negative 3. In order to figure out the rest of the information, I have to find the value of p. So the value of p is always 4 times some, let me say that again. This number is 4 times p. So 8 equals 4p, so that means p equals 2. Because the x is being squared, I know it's opening vertically. Because p is positive, I know it's opening up. So just kind of off to the side, I'm going to sketch it very badly, but you get the idea. That's what the parabola is going to kind of look like. It's going to have a vertex. The focus is here inside of it. Notice that as I've sketched it, the x-coordinate is the same. So the focus is going to be 4 comma something. Well, it's p units up from the vertex. So what's 2 spaces up from negative 3? Negative 1. Similarly, the directrix is going to look like this. That's a horizontal line, so I already know that's going to be y equals something. And similarly, this directrix is p spaces below the vertex. So what's 2 spaces below this? It's negative 5. And then finally, the axis of symmetry, that's this line. That's going to be a vertical line. So it's going to have the equation x equals, notice, 4. And then we graph it. So our vertex is 4, negative 3. And then I need maybe 1 or 2 extra points. Well, I can plug in a number and then use the axis of symmetry to get another point. So, for example, I can plug in 1 for x. I'm sorry, not 1. My vertex is at 4, so maybe I want to plug in 5. So if I plug in 5, I've got 5 minus 4, which is 1. 1 squared is 1, equal to 8y plus 24. I'm getting ahead of myself. So 8y equals negative 23, and y is negative 2.88. So that's going to be pretty broad looking parabola here. And if you can guess, as far as a paper pencil test, this is about as specific as I'm looking for. Maybe it'll be multiple choice. And this is the big ticket item, especially for any assignment quizzes in my class. Similar idea here. I have to figure out what P is. 2 equals 4 times P, so that means P is 1/2. So I know it's opening in a positive direction. Because it's the y that's being squared, I know it's opening right. So my vertex is right here staring at me. It's negative 6 comma negative 1. My focus, notice it's going to be P units to the right. So right is a horizontal distinction. That means it's my x coordinate that's changing. So my y coordinate is still going to be negative 1. So half a space to the right of negative 6 is negative 5.5. So there's my focus. My directrix is going to be a vertical line to the left of my vertex. So 1/2 to the left of negative 6 is negative 6.5. Equals, it's a vertical line, so that's x. And then what else do I need? Axis of symmetry. That's going to be a horizontal line, so it'll be y equals, and again, notice how the y coordinates of the vertex and the focus are the same. That's the number that y equals for my axis of symmetry. And then I graph it. My vertex is at negative 6, negative 1. 1, 2, 3, 4, 5, 6, negative 1. So maybe, oops, I never put this number in. Maybe since this is opening to the right, instead of plugging a number in for x, maybe I'm going to plug in a number for y. So since this y coordinate is negative 1, I'm going to plug in 0 for y. 0 plus 1 is 1. 1 squared is 1. So 1 equals 2x plus 12. So 2x equals negative 11, and x is negative 5.5. 1, 2, 3, 4, 5. I use symmetry to get this other point, and then I just kind of connect the dots from there. So I said if y was 0, x would equal negative 5.5. In example 3, this time the equation is not in standard form, so we need to move and shake it until it gets there. So you need to be really careful about what number goes where. Consider these two forms of the equation. Remember that I have tried to stress upon you as many times as I possibly can. For example, if I take x minus h quantity squared, that is not x squared minus h squared. I would have to FOIL this out, and somewhere in the process I would get an x term. So notice how here my x is being squared, but I don't have an x term. So that means that the number that's inside of this parenthesis with the x getting squared, that's 0. Okay, so that's kind of convenient to know. So this is going to be x minus 0 squared, which means I want to bring everything else over to the right-hand side. So that'll be 4y plus 4. Let's again consider what this equation is supposed to look like. 4 times a number, and that number could be 1, and then y minus k. So notice how 4 is a common factor here. That's convenient. I'm going to factor that 4 out and get y plus 1. So that means my vertex, once again staring at me, is 0, negative 1. Because the x is being squared and because the p-value is positive, this is opening up. And again, the main reason why I'm sketching it off to the side is just so that I conceptually have an idea of, okay, here's my vertex. The focus is going to be p spaces up from my vertex. P is 1. So it's going to be 1 space up from the vertex. 1 space up from 0, negative 1 is 0, 0. My directrix is going to be a horizontal line 1 space below my vertex. So 1 space below that is negative 2. This is a horizontal line, so it has the equation y equals negative 2. The axis of symmetry is a vertical line, so it has the equation x equals, notice these x coordinates that are the same, so that's 0. And now that I have all the information about it, now let's go ahead and graph it. My vertex is at 0, negative 1. And if I plug in 1 for x here, I get 1 minus 0 is 1. 1 squared is 1 equals 4y plus 4. Subtract the 4. I've got 4y equals negative 3. So y is negative 3/4. So when I plugged in 1, my y-coordinate was negative 3/4. So another kind of wide-looking parabola. Part B, notice this time the y is being squared. I also have a y term. So that means that unlike in this example, there's actually a number inside of this quantity other than 0 getting squared with the x. So we need to be very careful here. First of all, let's make this equation a little bit easier to look at. Notice that it has a common factor of 3, so I can take the whole equation and divide it by 3. So that'll be y squared plus 2y plus 5 equals 4x. So that's a little bit easier to look at, but now I've got to figure out what number is sitting inside of the parenthesis with the y such that when I FOIL it out, I get this 2y. We did this before at the very beginning of the year. We completed the square. All right, so I'm trying to find out what number I need to add to this expression in order to get a perfect square trinomial. Remember how to do that. You take this term, divide it by 2, and square it. So 2 divided by 2 is 1, 1 squared is 1. So two different ways that you can finish the rest of this problem out. You can realize, hey, I've got this 5 here, so I'm just going to break it up into a 1 and a 4, and then I don't have to add something to the other side of the equal sign. Or you could have just brought this 5 down and added 1 to the other side of the equal sign. Either way, you'll end up in the same place at the end. Okay, so equals 4x. So now this is a perfect square trinomial. It's equivalent to y plus 1 quantity squared. Remember, once you've got the squared term, you want everything else on the other side of the equal sign. So I'm going to subtract this 4, and I get 4x minus 4. Remember that I need this factored, so I'm going to factor the 4 out. It's a common factor, so that's convenient again. So remember that this 4 equals 4p, so that's why p will equal 1. And then the vertex is right here staring at me, 1 comma negative 1. Since the y is what's being squared and the p is positive, this graph is going to kind of look like this, opening to the right. So here's my vertex. My focus is somewhere inside to the right of it. Here's my directrix. So my focus is one space to the right of my vertex. So that's 2 comma negative 1. My directrix is a vertical line, so I know it's going to be of the equation x equals, and it's one space to the left of my vertex, so that's 0. My axis of symmetry is this horizontal line having the equation y equals the y coordinate of these two things, so negative 1, and now I graph. My vertex is at 1, negative 1. I know it's going to be opening to the right. As I did in example 1 part B, since the y is being squared, I could think of the y as the independent variable and the x is dependent, so I'm going to plug in 0 for y and figure out what x is. So when I plug in 0 for y, I get 1. 1 squared is 1 equals 4x minus 4. So 4x equals 5, and x is 1.25. So 1.25 is here. I can use symmetry to get this point as well. Whoops. Let me do that, talk through that again. There's my vertex, 1 comma negative 1. And then I did this algebra to figure out that if y equals 0, then x will be 1.25. I plotted it here and used symmetry to get this point as well. And then here's basically my graph. In example 4, the instructions say write an equation for and graph. I'm only going to be focusing on writing the equation for it, and I'm not looking at this at this time. Okay, so my focus is negative 6 comma 2. My vertex is negative 6 comma negative 1. First thing that I would suggest that you figure out is how this graph is opening, up, down, left, or right, because that determines whether your p-value is positive or negative, and it determines whether it's the x being squared or the y being squared. Okay, so kind of off to the side, here's part A. If my focus is at negative 6 comma 2, so there's my focus, and my vertex is at negative 6 comma negative 1, well, remember, the focus is always inside of the parabola. So that means my graph kind of looks like this. So I know it's opening up, which means p is positive, and that it's my x term being squared. So x plus 6 squared equals, and I'm going to figure out the p-value in a moment, and inside the other parenthesis, I've got y plus 1. So let's talk about that p-value. Remember, the p-value is the distance between the vertex and the focus. And it's going to be 4 times that I write down in this blank. All right, so how far away is the focus from the vertex? Well, notice that the x-coordinates are the same. So how far away is 2 from negative 1? It's 3 spaces. 3 times 4 is 12. So there's my answer for part A. Similar line of thinking for part B. So For part B, again, kind of sketching it so I have an idea of what's where. My vertex is at 5, -2. My vertex is at 9, -2. Remember that the focus is always inside the parabola, so that means this graph is kind of behaving in this manner. Sorry, let me go through that again. Sorry. So I plotted kind of sketching where my focus is, where my vertex is. Remember that the focus is always inside. So that's why I know it's opening to the left. Since it's opening to the left, I know my p-value is negative, and I know that it's the y inside a parenthesis being squared. Okay, so y plus 2 squared equals, and we'll figure out what 4p is in a moment, x minus 9.